So, as mentioned in the email this video is attached to, Dave wants to practice vertical circles for a flying show exhibition. There's two parts of this question, and part A is asking, what must the minimum radius of the circle be to ensure that his acceleration at the bottom does not exceed 3.0 g? The speed of the plane is 78 meters per second at the bottom of the circle. Part B is, what is Dave's apparent weight at the bottom of the circular path? Express your answer in terms of his true weight. Well, for the minimum radius, we can use the maximum possible radial acceleration, since a sub r is equal to v squared divided by r. And for the maximum radial acceleration, the tangential acceleration must be 0. Now, the magnitude of the acceleration is a is equal to the square root of a sub r squared plus a sub t squared. And because of this, the radial acceleration component has a magnitude of 3.0 g at the bottom. And then to find Dave's apparent weight, we don't need to use his numerical value of the radius found in part A, because we already know that his acceleration is upward and that it has a magnitude of 3.0 grams. Now, in my force body diagram, if you look closely, you can see a poorly drawn plane that looks like a square. But it shows the acceleration going towards the center of the circle and the velocity going 90 degrees out at a tangential angle. And now the magnitude of the radial acceleration is a sub r is equal to v squared divided by r. And we can go ahead and solve for the radius with using the formula r is equal to v squared divided by a sub r is equal to v squared divided by 3.0 g. And all I did was plug in my values for that. And I got that it is equal to 210 meters. Now, moving on to part B, which again was, what is Dave's apparent weight at the bottom of the circle path, and express your answer in terms of true weight. Dave's apparent weight is the magnitude of the normal force of the plane pushing up on him. So right there you can see I let the y-axis point upward with the normal force pointing up and the gravitational force pointing down. So it gives me this formula here, which is the sum of the forces in the y direction is equal to n minus mg is equal to the mass times acceleration in the y direction. And the acceleration in the y direction is equal to the 3.0 grams, 3.0 g, not grams, which then gives us the formula for the apparent weight is equal to the normal force is equal to the mass times the gravitation plus the acceleration in the y direction is equal to 4.0 mg, and this means that his apparent weight is 4 times his true weight.